We'll start our do now with a little bit of review of some of our previous work. Here we have a consumer math problem. We have 2/9 off the original price. The sales price is $126. What is the original price? So when we think about this, visually speaking, we're starting with an original price that is unknown. And we are breaking it into 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. 2/9 of those pieces will be taken off, leaving us with 7/9 of that original price. 7/9 of the original price, which is 7/9 of x, is equal to our price of $126. What we should see is, since we have the original price, we're going to expect that this is going to be larger than 126 since it was on sale. So it should be C or D. We multiply, or we divide both sides by 7/9, which ends up being the same thing as multiplying by 9 over 7. So x is equal to 126 times 9 over 7. If we go ahead and do the math behind that, we should get 162, which is actually the answer choice on your classwork. 162. Alright, moving on to the next one. Next one, we have a shoes that were marked up. The store purchases the shoes. That means originally they paid $28 for them. And they added 2/7 of the original price. So I need a second bar for what was added on. And so this is 7 out of 7 for this original one whole. 1, 2, 3, 4, 5, 6. And we have an additional 2/7 added on. So of the original price, we have 9/7 of the original price, which is 28, is going to be equal to our unknown value, our marked up price. We should do that math and we should get $36. Answer choice C. Alright, let's flip on over and look at our aim. Today's aim, Kipsters will be able to graph and interpret graphs of proportional relationships. So really this is a review of a lesson that we did a little bit more than a week ago. Difference is we're going to have some fractional pieces in here. That's going to change things up a little bit. So Kipsters will be able to graph and interpret graphs of proportional relationships. Alright, so look at this first problem. Sam's mother has entered a 10K race. Sam and his family want to show their support of their mother, but they need to figure out where they should go along in the race course. They also need to determine how long it will take her to run the race, so that they will know when to meet her at the finish line. Previously, his mother ran a 5K race in a time of 1 1/2 hours. So we're going to assume that she runs at the same rate as her previous rate. We're going to complete the t-chart. So in order to complete the t-chart, we're going to go ahead and throw in one of these values, the one value we already know. Take a second to read through the problem and put the pair in that we do already know. Should recognize the pair that we do already know is 1 1/2, 1 1/2 hours is 5 kilometers. So we should be able to use that to kind of think through the rest of this. We know that if she runs nothing for no hours, she will be 0 minutes. And then we can kind of jump through this. 1 1/2 times 2 is going to give me 3. Times 2 would give me 10. We could continue to jump through this. We can multiply this by 2. That would give me 20. And we could multiply the original by 3, which would be 4 1/2, and 15. And if we take the original and multiply it by 5, we'll get 7 1/2 for 25. All right, so coming over here, we'll go ahead and graph this value, these values, for time in hours. So obviously we're starting at 0, 0. And then 1 and 1/2. So 1.5 hours is going to be kind of along here. And it's going to be a graph around 5. And 3 is on here for 10. And let's see, we also had a 4.5 that's not going to fit on there. So these are the points that we have that will fit. If we draw a straight line, it should graph something like that. Alright, so create the table, see how far they've run after specific time. So what are some of the specific things we notice about the graph? There are two specific things that if we think back to the lesson before about graphing proportional relationships, we should be thinking about. Have those two things in your mind. So what you should have in your mind right now is that you notice that it starts at 0, 0. And it graphs a straight line. So it starts at 0, 0 and graphs a straight line. What is the connection between the table and the graph? So as we look at the graph and the table, we should see that the hours are on the x axis and the kilometers on the y. All right, and finally, what does the ordered pair 2, 6, and 2/3 represent in the context of this problem? So think through this really quickly about what this represents in the context of the problem. This means going back to the units for x and for y, kind of determining what that means in relationship here. Go ahead and have your thoughts in your brain. So as we go back, we should see that our x's are hours. So this means that in 2 hours, coming over here to y, y is the number of kilometers that she's run. In 2 hours, she runs 6 2/3 kilometers. So going back to this, there are a couple places we can talk about finding the unit rate for this particular problem because we don't quite have the unit rate here. So let's go ahead and think through a couple of places where we can find the unit rate. Go ahead and find the unit rate one place on your own. Alright, so remember when we're talking about a unit rate, we're talking about the number of y for x, so for one value of x, and one way we can find this is by putting our y over x. This is going to give us 10/3 or 3 1/3 kilometers per hour. We can also think about it in terms of our graph over here shows us that this is much less precise, but this point would be 1, 3 1/3. So remember, we can also use our graph to help us determine the unit rate if we can find out how much for 1x. Like I said, less precise here, but it is something that we could use to make an estimate here. 3 1/3 miles per hour. We can also use this to write the equation for this situation, which would be y is equal to, I'll use the improper fraction form, 10/3 x. And that's really it, the basics of our lesson. Again, it's pretty much review, except we definitely do have some different values moving on here, the equations with fractions. So let's go ahead and pause now this video. You can go ahead and move on to your partner work time, work through your partner work time, and then go ahead and jump back into the video to check it out. Okay, as we get to looking at this, our first question asks us if this situation is a proportional relationship. It asks us to explain how we know from examining the graph. All right. So when we look at the graph, we notice two things about the graph. One, that it starts at 0, 0, and another, that it does form a straight line. So does this form a proportional relationship? Absolutely it does. We know this because it starts at 0, 0, and goes through and goes in a straight line. All right, what is the unit rate in costs per pound? So there's a couple of different ways we can think about this. We want to know in the cost per pound. So that means we would need to know this value here if we wanted to look at it directly from the chart. We could calculate it, y over x, which would be 4 over 1/2 here. So 4 divided by 1/2. Which would be equal to 8. Or we could also come over here and see it on the graph at this point where we see it is 1/8. So that helps us answer this question. For 1 pound, it would be $8. So our unit rate here is cost per pound is $8 per pound. Writing an equation to model this data. So this is a super simple thing. Once we've got the unit rate, we know it's proportional. This is y equals kx, so y equals 8x. What ordered pair represents the unit rate, and what does it mean? Okay, so we've already seen this and talked about this already. That unit rate is that where x is equal to 1. So we see that pair here, 1, 8. And that means that for every pound we purchase, we pay $8. For every pound, we pay $8. All right, what does the ordered pair 216 mean in the context of getting this problem? So this is our x, which is in pounds. We purchased 2 pounds of meat. If we purchase 2 pounds, the cost is our y, $16. If you could spend $10 on mushrooms, how many pounds could you buy? So this means we're going to go back to our equation. Hopefully you've gone back to your equation to do this. Y is equal to 8x. $10, that is a cost, so that goes into our y, is equal to 8x. Divide both sides by 8 to solve the equation. We'll get 10 over 8, which is equal to 1.25 pounds. X is equal to 1.25. And finally, what would be the cost of 30 pounds of mushrooms? So y is equal to 8x. X is our amount of pounds, so y is equal to 8 times 30. So y is equal to 240 nope, not pounds. Y is in terms of dollars, $240. And that's as simple as that. We can finish filling in our chart because we actually see this point up here, 216, so we actually don't have to do any solving to fill in that chart. And that's it. Really, just the basics of knowing what the coordinate pairs mean and how to use them.